Today's lesson, we are going to look at organic molecules, chemistry 1502. We are going to focus on alkanes. This is lesson 1. Let us start. Before we get into details, we need to understand what is organic chemistry and what is organic molecules. Organic chemistry is the chemistry of carbon compounds in living and non-living systems. Organic molecules, molecules containing carbon atoms. Now, this chapter we are going to focus mainly on carbon and hydrogen. Those are the most common or basic elements we are going to use, which is carbon and hydrogen. We need to understand their properties. Carbon has the ability to bond 4 times. We say it's tetravalent. And then hydrogen has the ability to bond only once. These are important aspects we need to take note when you're dealing with this chapter. Alkanes. Alkanes are homologous series that consist of a single bond between carbons. So what is important, you need to understand and take note that alkane, it only consists of single bond. We are going to explain that in detail. Now the suffix of alkane is ane. It simply means that each compounds which belong to alkanes, the suffix, the ending name will be ane. Now we are going to look at the first 10 compounds which belong to alkanes. These are the names of the first 10 compounds which belong to alkanes. Now looking at number 1, we have methane. Number 2, it's ethane. Number 3 is propane. Number 4 is butane. Number 5 is pentane. We have hexane as number 6. Number 7 is heptane. Number 8 is octane. Number 9 is nonane. Number 10 is decane. Now let us look at what is common with these compounds. Now you can see that the ending 3 letters is ane. So this is how we differentiate the compounds belonging to alkanes, and the other compounds will have a different suffix. So I hope you can see this. What is important, you need to know and master this. Number 1, it's methane. 2, it's ethane. 3 is propane. 4 is butane. 5 is pentane. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. 10 is decane. If you look at or watch the lesson video based on the next homologous series, which is alkenes, you will actually see the difference. Our next part of the lesson, we are going to look at structural formula and molecular formula. Now, what is the structural formula of methane? As we said, methane is the first carbon. So it consists of 1 carbon atom. Now remember that carbon is capable of bonding 4 times. So it will be carbon bonding with 4 hydrogen atoms. So this is the structural formula of methane. Now what is the molecular formula? Molecular formula, we have 1 carbon atom and 4 hydrogen atoms. So this is the molecular formula of methane, and then this is the structural formula of methane. Let us look at the next ones. This is the structural formula of ethane. Now how many carbons do we have? We have 2 carbons, and then hydrogen we have 6. So this is the molecular formula of ethane. This is the structural formula of ethane. This is the structural formula of propane. That is compound number 3. And then we can see we have 3 carbon atoms, and we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atom. So this is the molecular formula of propane. This is the structural formula of butane, which consists of 4 carbons. And when you write the molecular formula, it will be C4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. This is the molecular formula. What is important, you need to make sure that carbon has 4 bonds. As you can see, this one we have 1, 2, 3, 4. And then for this one we have 1, 2, 3, 4. Just make sure it doesn't exceed 4 and it remains 4. So these are examples of structural formula and molecular formula. We can go on to decaying, but it's simple. As long as you know that decaying consists of 10 carbons, you make sure that each and every carbon has 4 bonding ability, and then everything is simple. Our next part of the lesson, we need to understand where do we actually get the molecular formulas of each compound. Now, alkanes has a certain equation, which is CnH2n plus 2. This equation is only applicable on alkanes, whereby n is the number of carbons. So suppose we are looking for the molecular formula of ethane, which consists of 2 carbons and 6 hydrogen atoms. Now from this equation, how can we predict the structural formula and the molecular formula? So where we see n, we are going to substitute by 2. Since ethane it actually represents 2 carbons, so it's going to have, we are going to have C2H2 2 plus 2. So it's C2H2 multiplied by 2. 2 multiplied by 2 is 4. 4 plus 2 is actually 6. So this is how we derive the molecular formula of ethane from this general formula of alkanes. Let us look at another example. Suppose you are looking for the molecular formula of hexane and also the structural formula. So remember, the general equation is this. So hexane, we know that it's 6. So you are going to substitute 6 H2 plus 2. So you have C6, 2 multiplied by 6 is 12. 12 plus 2, we have 14. So drawing this, this is the structural formula. We are going to attach hydrogen atoms, so we can count this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you can see that it obeys this molecular formula. 6 carbons, 14 hydrogen atoms. Our next part of this lesson video, we need to go through condensed formula. We need to know how to represent or write down condensed formula of a given compound. Now, for example, let's say we have ethane, and then this is the molecular formula. What is the condensed formula? You will see the difference. Condensed formula will give a summary of each carbon. So the first carbon, we have how many hydrogen atoms? 1, 2, 3. So it will be CH3, and then the next carbon, we have 1, 2, 3. We are going to have CH3 again. So this is the condensed formula, this is the molecular formula, this is the structural formula. Another example is propane, which consists of 3 carbons. And then what is the condensed formula of this? It will be CH3. Since you can see the first carbon consists of 3 carbons, 3 hydrogen atoms, and then we have CH2CH3. This is the structural formula. Now the outline of this lesson video, you need to understand and master the compounds methane, ethane, propane, butane up to decane, and then you must be able to draw the structural formulas. You should be able to know how to write down the molecular formula from the derived equation or the general equation. You need to also know how to write down the condensed structural formula. That's it for this lesson video. This is Wahula SJ. Thank you very much.